Alright, this problem seems super hard. There's a point where this helicopter is going up at a constant velocity. This guy holds a briefcase that's also going up at a constant velocity. So once he lets go, it's going to go up, come to a stop, and then fall down to the ground. He let go at 130 meters, so it still went higher than 130, and then it came to a stop, and then it fell higher than 130 through the 130 mark. The entire trip took 6 seconds. So, there's a lot going on here. This is a super hard question. This is about as high level as they get. What we need to do is, what else? Is there anything? Yep, all the information they gave us. We do know acceleration is negative 9.8 meters per second squared. That's about all I know, but this is the key thing. He lets go at 130, it's still going upwards. So let me think this one through. So here's what we're going to have to do. We have x final equals x initial plus initial velocity times t plus 1/2 a, which in this case would be gt squared. What I'm going to do is I'm going to take this and put it over there and combine these two things. So I should get I'm sorry, I wrote the wrong subscript there. It should be final minus initial. I have to subtract this final from both sides. Whoops, let me get back to a pen here. Sorry, forgot to turn that on. And then I'm going to go through and multiply everything by -1. So it would be, this turns into x minus, and then this is minus 1/2 gt squared. And I need more room again. Alright, so this will be my initial velocity that goes for a certain amount of time, which I don't know what that is, but you'll see in a second. This would be negative 130 meters minus 0.5, gravity's negative 9.8 meters per second squared, and the entire trip was 6 seconds, which is squared. So basically I have to do this piece, because it's negative 130 meters minus this, so it's 36. I'll put this in my calculator. 6 squared, turn the calculator on, times negative 9.8 times 0.5. I get negative 176.4 meters. Sorry, I misspoke. This is a plus, right? We have a negative here and a negative negative here, so that's plus 176.4. Boy, I'm really messing this up. So what we're getting is the velocity initial times some sort of time equals this distance that it went up. Remember, it went up for a while before it came back down, and that would be 46.4 meters. Now, when I solve for velocity, I put my 6 seconds here. I'm going to divide both sides by time, which was 6 seconds, and I get 7.7 meters per second. Now this doesn't seem right to put this 6 here, but remember, this thing went up, came to a stop, and came back down. So it really looked like this. And that initial velocity kind of came out in the wash when we started subtracting distances that were plus and minus. And the initial velocity was up, and the final was way down at the bottom. So 7.7 meters per second. That was long and hard, but there it is. Woo woo, woo woo.